Hello one and all, and most welcome to my channel. In today's tutorial I am going to talk about circular elevated water tanks using ETABS finite element software. This is ETABS software. I am going to start a new model here. I am going to new model, hold control plus in. I will not save this one. So now I am coming here to the model analyzation. I will choose here the display unit will be metric standard international, and the still section database will be this one. Afterward it is code, and concrete design code will be American Concrete Institute 318-2019. Now I will put here the number of stories will be 5, and this will be 3, the typical story and bottom story, and other spacing I will put as it is. Afterward I will modify the grid system. Now I'm just pressing the grid only, press OK. So now I will modify the grid lines and will make it cylindrical. So I will modify this one. Here, and it is story height, it is 3 and it is 5 meter because it is the water tank. Afterward, in the total elevation the total elevation height is 17 meter. Okay, now I will add new grid here, new grid system. The grid system type is cylindrical. Now the number of grid lines in all direction is 6 meter or 6 number, and here it will be 6. Afterward, if there was mistake I will modify, and here the spacing is 3 meter, and I will modify here again. I will make it 360. I will modify here again. I will reduce here the bubble size. So now this is the real view, this is the plan view, and this is the elevation grid line system. So if you do not understand well, so you will add here the grid system as a cylindrical here. Afterward, if you see it is modification, look here, this is the grid lines about like X and Y, and here is the angle from 0 up to 360 degree. So it will be like cylindrical. Now I am coming here, I want to close all the bubbles, like make bubble as an N. All the bubbles will be invisible after this modification. Okay, and press OK. Still the two grid lines is visible here. I will modify here again. I will make it also invisible. So now this is the cylindrical water tank. So now I will come here to modify its material properties. I will modify here it is concrete material. It will be 4000 psi as a concrete material. I will make it its unit weight as a 25 kilonewton per meter cube, and will make it this one 30,000. Okay, megapascal, and afterward I'll press OK. and this will be the rebar material. I will do not change any properties. I will just press OK. So I will use 4000 psi as a concrete material and 60 as a rebar material. Okay. Now I am coming here to modify the section properties of frame sections. I will delete here the multiple properties. Okay, I will do not need this one. I will delete all. Press OK. I will add new property here. I will choose here as a concrete rectangular. I will just click concrete. I will give a name here as a beam 4.4 by 0.4. It is a meter. I will choose here it is material 4000 psi, and I will give a section here as a depth 400 mm and width 400 mm. I will show it is modifiers. You can change here or it is correct. I will just select here design type is a beam, and it is material is 60 for rebars. It is top rebars and bottom rebars. Afterward OK and press OK. I will delete this property. Now I will add new property here. This time I will choose here as a circular section for columns. I will give a name here. I will put a name here as a column 0.5. It is circular. I will choose here it is material and it is 500 mm. I will put here modifiers. As a moment of inertia about axis 2 will be 0.7 and about axis 3 will be also 7. I will press OK and modify the rebars. It will be 60, and here I will do not change any other things, but I will choose here the PM2 and 3 design, which is for column. I will press OK and will press OK. I have defined beams and column. I will proceed. Now I am coming here. I will define here wall section for water tank. I will add new property. I will put a name here water 25 and will choose it as material. Afterward modeling type is shell thin and it is thickness is 250 mm. Press OK. I will delete the previous one and press OK. Now I'm going to define it as slab section here. The slab sections. I will add a new property. I will give a name here. The slab 300. What I will put bottom slab 300 mm. I will choose it as material. It is modeling type is shell thin. It is property type is slab and it is thickness is 300 mm. I will proceed. Now I will add a copy of this property. It is roof slab. It is 150 mm. So because we do not have much more load in it is roof, that is why it is thickness is this. It is material. It is property type and it is thickness 150 mm and press OK. I will delete this one and this one as well. So I have defined it as bottom and roof slabs and proceed. Now I have defined material properties, the frame section, beams and columns, and also wall and slab. It is OK. Now I am going to here to model. I am coming here for the wall section. Here I will choose draw walls. I will choose here as a wall. and I'm coming here to specify and select as a one story. I'm coming to it is plan view as a story 5. Now I will draw a wall or shear wall. You can look here, it is previewed in 3D as well. Afterward, this one, this side, or if you want to just quickly draw it, you will choose here the quick draw wall. You will select property as a wall, and you will just select the grid lines. So the wall is going to draw automatically. It is for elevated cylindrical water tank. And complete. Afterwards, press escape or just this one. Now look here, the wall has been created. This is a wall for elevated cylindrical water tank. Very simple. So now I'm coming here to define it is slab sections. Now I'm coming here. I will choose here it is property as a slab, bottom slab, or the roof. So now I will select from here up to here, coming to this point and all through the grid points of the roof slab. And back through the initial point, which was the grid point B2. After, press escape. So this is the slab for roof water tank here, for it is roof. Now I'm coming here one step down. Now I will create here at a slab, or before that I will just draw it is beams. I'm coming here to quick draw beams. I will choose here the beam properties. It also is I will select now beam. Now see, if I select once, all the beams will be applied on other grid lines as well. Escape. So look here, I have created beams as well, beams in wall, and here as well. So this is the roof. We do not need any beams here because there is a wall. I will delete all these beams from the roof of the water tank. So now I'm coming here one step down. Now I will draw it as bottom slab. I will select here for the slab as a bottom. So I will select one story. I will select all the grid points. and buckle it is the initial point. So I have created it is bottom steps also. Look here, it is bottom step. So now I'm coming to draw the columns. Now I'm going to here to draw it is columns. So I will select here the quick draw columns. I will choose here it is column properties here. Now I'm coming here to choose all stories and I will draw the columns here. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9 grids lines, and so it is not symmetrical. So I will choose here column here and here, here and here. So the 4 columns is enough. So if there was need, I can just draw another column as well. So I have created the columns as well. Now I'm coming here to it is base. I will select OK. I will choose one story. I am going to make it fixed. The supports I will assign joint as a restraints. Fixed. OK, and proceed. Now I have drawn all the structure element of the elevated cylindrical water tank. So it is beams, columns, wall, slabs, supports, everything. Okay, so make sure this water tank will be empty, means there will be no water, but afterward in the next tutorial I will do it for it is water, like for water pressures and others. But at the moment for this modeling, this water tank will be empty, there will be no water exist for in other fluid, but in the coming tutorial I will do it for water as well. But it is water tank, but it is empty. That is why I am going to check its performance for earthquake or seismic forces of elevated cylindrical empty water tank. So means do consider this water tank will be empty, there will be no water, and in the coming tutorial I will do it for full of water or any other liquids as well. So now I am coming here to define it is load patterns. I will define here earthquake X positive. So it is seismic and it is code is 716. American Center I will add, and earthquake X negative, add earthquake Y positive, the same code, earthquake Y negative, the same code. For wind X, I will choose here the type as a wind and American code, and for wind Y as well, the same code. So afterward I will modify here the earthquake. I will choose the X plus eccentricity. I will uncheck other boxes, and I will here the structural acceleration SS value will be 1.15 and this one will be 0.51. So it is site class is B this time. Afterward it is time period is system calculated, and I will do not change in other values, where I will put here as a response modification will be 8 or 7.5, and also here it is importance occupancy is 1 or 1.1. 1 is okay. I will press okay, and I will modify here. It is x directions minus eccentricity. SS value is 1.15 and this one is 0.51. It is side class is B and it is response modification factor is 7.5 and proceed. Same as for earthquake y-axis, y directions plus eccentricity, and SS is 1.15 and here is 0.51. The side class is B and modification response modification factor is 7.5. Press OK. Same as for Y, modify. I will uncheck other boxes. Y directions minus eccentricity, SS is 1.15. This one is 0.51. This side class is B and it is response modification factor is 7.5. Press OK. Wind X, it is exposure. Speed of the wind is 100 and the exposure type is B. So it is exposure height is starting from the story 1. Okay, and also for y direction, exposure of wind speed is 100. Here starting from exposure height story 1. Press OK and proceed. So I have defined it is load pattern as well. Now I will define here it is load combination. I will undefault concrete frame design. Press OK. The total 26 load combination will be added here. Press OK. Now I'm coming here to define its mass source. I will add new mass source. I will put a name here. I will put a name here as a mass source. I will uncheck these boxes and I will add here their load modifiers as 1 and also the live load modifiers as 0.25. I will add here also and press OK. And I will delete the previous mass source. I will press OK. Now I have defined it is load combination, load pattern, and it is mass source. Now I'm coming here to apply the dead load and live load for slabs. I'm coming here to it is bottom slab. So here this is the 3D view. So first I am going to calculate it is dead load. I will bring calculator. It is thickness is 0.3 multiply 25. So it is 7.5. So I will select this bottom slab. I am going to assign here as a shell load uniform. It is dead load and here it is 7.5. Gravity apply. So press OK. Now I am coming here to apply the live load as well. So I will select the object type as a slab here or floors. Select. So I will apply here as a shell load. So this time live load and it is 1.46 and add to the existing load, apply OK. Now look here, the live and dead load has been applied on this slab. Okay, so at the moment for this modeling and designing, I'm not going to apply it is water pressures because this water tank is empty, there is no liquid or water. In the coming tutorial I will do it is analyzation for water as well, so in that time I will apply the water pressure as well. Okay, now I am coming here. So now I am coming here to define it is response spectrum. I will put here code or American Society of Civil Engineering 716. I will add a new function. I will put a name here, target response spectrum. So it is SS is 1.15 and S1 is 0.51. Decide classes B here. So now you can look here for it is period and acceleration here. It is damping ratio is 5%. Look here, this is the graph. So you can look here, it is value here. If you just moving the cursor, I will press OK, or you can just do convert to user defined as well. So I will delete this one. I will put OK. Now I'm coming here to define it is time history, as I'm going to do here the nonlinear dynamic analysis for this structure. So and I will use here from the file, but before that I have to have the electric records. So I will put that electric records in the folder where I have saved this model. So first I am going to save this model here. For example, I am going to save it in download. I will create one folder here. I will wait it. So I will put here this folder. I will give a name here as a abbreviated. I will press OK. So now I am going to put some electric records in this folder. So and here startup structure for electric. Here I will just copy this electric record, where I have saved this model. I will paste it. So now I'm going to add those electric records in X and Y direction. If you do not know from where to get to the electric records, watch another tutorial which link is in the description box below. So I'm coming here to the time history, select here from the file, press OK. So now you can select here from the file and select add new function. You can browse that electric record in the download, and here in the download you can choose for electric record X direction. You can put here the time history analysis for electric X directions Italy. So I will skip, it is 4 lines. You can look here, it is file 1 2 3 4 lines to be skipped. Afterward the number of points per line is 5. Come here 1 2 3 4 and it is 5. It is not completely visible. So and the time, it is time difference is 0.0024. So I will put here. Now look here, it is the time history graph for this earthquake. Afterward I will press OK. Now I'm coming here to define for earthquake y-axis as well. I browse that earthquake code about y-axis. I will rename it as a time history analysis for earthquake y-axis Italy. So the number of lines will be skipped is 4 and 5 here, and it is time difference is 0.24 as I have shown you here. So this is the graph for earthquake y-axis here. Now I will press OK. I will delete this one, there is no need. So I have defined it is earthquake time history for earthquake x-axis and y-axis. I will delete this one also. So in this model I will do not do it is matching with the response spectrum, but in previous tutorial for another water tank which was for rectangular elevated water tank, you can just look for it is matching, but this time I will do not do here. I will press OK. So now everything is correct. I will just select here, select object type as a floors, select, and I am going to assign here it is diaphragm and OK. So now everything is correct. I am going to here to start run analysis. Afterwards I will show you the analysis result of this elevated cylindrical tank. Okay, I will press yes, run analysis. The analysis is going to complete shortly. So it has been completed. We will see whether some elements is going to fill or pass. I'm not sure. Let us check it is design check. So now let us see, verify all member passed. Yes, all concrete frame passed the design check, so it is good. You can do here it is other information as well. For example, it is rebar percentage. Look here, it is the rebar percentage, and other information you can do from here as well, like column KM 2M3 interaction ratio. You can check from here. You will select this column and go for it is details. Look here, it is the concrete frame column information here. You can check from here all the details. So now I'm coming here. So if you just wanna check all the other information, you can do it from here. If you wanna check for it is wall, shear wall design check, you can do from here. Now I'm coming here to display here the frame piers. For example, as the earthquake x-axis, I am going to look at its shear 2. I will just apply Look here, it is the shear to about earthquake x-axis. If you want to just draw for some combination, you can do from here. Look here, all the values is visible here. If you wanna draw it is moment 3 you will select here. It is combination and it is momentum 3. Afterward apply and OK. So here is the moment. Now I'm coming here. You can check for other combination as well, or earthquake as well. For example, earthquake Y. Yes, OK. Look here, it is for earthquake Y. Here it is visible. Now I am coming here to see it is mode shape. You will choose here the mode shape and it is model and the number of mode shape, and we can just increase or decrease. You will see from here. Now I will show you also it is axial force. From here you will choose it is combination and press apply and OK. This is the axial forces of this elevated circular tank. So all the information is here available. So now I'm coming here to display, show table. Afterward here to the structure output, base reaction here. The base reaction will be here, and if you wanna just say other information here as well. So like for example, so first I will say it's base reaction or base shear. I will choose here as the earthquake Y index, not all other combinations. Apply multiple filter. Look here, it is the base shear about X and Y. We can just export this one to the Excel sheet as well from here. So look here, it has been exported. So I will make it done. Now I am coming here again to the display, show tables. This time I will just uncheck this one and I am coming here for here. So it is period and frequencies. I will select and will press OK. Look here, it is the period of the structure. This is the mode 1, mode 2, mode 3 up to mode 12. And this is the period 1, 2, 3, 4 and 5 and others. And this is the frequencies in hertz. This is the period. If you want to just export to the Excel sheet, you will come here, export the current table to Excel sheet. It will be exported automatically. Okay. Now I am coming here again to the show tables. I will uncheck this one. Now I am going to say it is story forces. Now I am coming here to check it is story forces. I will select story forces. You can choose here the load pattern as well, for which load you wanna just get it. For example, I want for a quick X and Y. I'll press OK and press OK again. Look here, this is the story forces, but it is for not only for earthquake X and Y, it is for all the moved only earthquake X and Y is in load pattern. Now coming here, like I was just unselected, I will select all, or just select all or clear all. Now I will say here it will be for earthquake X and Y as well. Look here, it is the story forces, so it is the torsion and others. Now I'm coming here again to the show tables. So I will uncheck this one. So if you want to just see and look for story stiffness as well from here, and it is other information, all the information is available here. So it is all. It was all about how to model, design and analyze elevated cylindrical tank using ETABS. I hope this lecture will help you. Do not forget to subscribe this channel and press the bell icon for getting the quick notification for all the uploads. Have a wonderful time. Bye bye.